All right. Hello, everybody. How's everybody doing? Welcome to Friday at chemistry here. All right. So what we're going to be doing is I'm going to be going over those homework problems you guys should have already turned in for, what is that, homework 8.5, limiting reagent. So I'm going to go over those and then answer any questions you guys have. Okay. But before we jump into that, I just want to say hi, open it up to any questions you guys have, and also mention that we are going to be having a test coming up real soon. Okay? So you guys, we have a test next week. We're all done with the material. And I was planning on having a test probably on Tuesday. Okay? So planning on having a test on Tuesday on all this stoichiometry stuff. That gives us basically, today I'm assigning the review, and then on Monday I'm going to go over all of the review problems. What day? Tuesday. Now, that is, unless you guys have a lot of other stuff on Tuesday. Okay, so I can be a little bit flexible, but I mean, there's no real reason to move it to Wednesday unless you guys have like 2 other tests on Tuesday. Okay, so what's your schedule like looking for next week? I mean, is next Tuesday going to work? Anybody? This is one advantage of being here for the live stream. You actually get to put your input into my questions, right? So I see all of 7 people showing up. All right, so just, yeah, so does Tuesday work? If Tuesday works, we're going to go with Tuesday. If not, I can push it to Wednesday, but it's definitely not going to be any other day. It'll be either Tuesday or Wednesday. Okay. Yes, I don't know about other people. You know, that's okay. I'm okay with other people not getting their input in here because they're not showing up to the live stream, which is fine. So if Tuesday works for everybody here in the live stream, we're just going to stick with Tuesday. All right, looks good. Okay, so test next Tuesday. I have already put up the review guide for you guys. It's up on Google Classroom. I think there's also a copy on OneDrive, but I mean, I haven't updated that recently. I think it's just I put that up last year on OneDrive. So you can check OneDrive, but I definitely put the assignment, the review guide up on Google Classroom already, just this morning, okay? Now, do we have to turn the review guide into Google Classroom? Yeah, I actually want you guys to. Although sometimes I say, it's optional. I just want to make sure that everybody's doing it and everybody knows what they're doing coming into the test. And it's going to be good for you guys, okay? So here's a heads up. Your actual test will look a lot like that review guide. It'll look a lot like the review guide isn't really just a normal review guide. It is a practice test. It is a previous year's test. And I can say right now, the one difference is going to be your actual test will not have any vocab. So there's no point in us having any vocab terms on this test. So the very first part of the review guide, you will see that it's got some practice it's got some, hold up, I just need to turn something off real quick. The very first part of the review guide has some vocab terms, and we're not going to have vocab terms on the actual test. All right, there we go. Back on, okay? So the practice test has some vocab terms. You guys will not have any vocab terms on the actual test, okay? Other than that, that practice test review guide is going to be very, very similar to the actual test, okay? In terms of the setup, in terms of the types of problems, in terms of how to solve the problems, all the same, okay? The only differences besides those vocab terms will be that you're obviously going to have different chemical reactions and different numbers, and that's about it, okay? All right, so let's go ahead and tackle this last homework. If you guys don't have any questions on the test per se, let's go ahead and tackle this last homework so that we are making some sense of it. This is what we started off with last time, the whole limiting reagent problems you guys did. You guys have the live stream from last time, and you also have that video that I made a while ago, which is limiting reagent made easy. So guys, make sure if you haven't seen this, definitely watch this. This is going to be a better quality video than my live stream, okay? So make sure you watch that, Limiting Reagent Made Easy, and it's going to go through everything you guys need to know about limiting reagent, okay? The video is kind of blurry. You mean today's live stream? Do we have to turn the review guide into... strange. Yo, my screen actually looks good. Sometimes my screen looks bad, but my screen kind of looks good today. I don't know what's going on. It might be blurry because we have some connectivity issues and some the network. And I don't think this is my network. My personal network is, I've got pretty good speed, or it might be your internet. It really actually might be Google, because Google has been overwhelmed lately with so many people live streaming and watching YouTube videos and various different things that it's literally overwhelming Google. But anyway, so let's go ahead and jump into the new stuff. All right. So limiting reagent, make sure you guys watch that at some point in time. Limiting Reagent Made Easy. I've got the link right here on my page if you look at the Google Doc, or you can just go to my my channel online, or you can literally type into Google or into YouTube Limiting Reagent Made Easy by Ketzbook, and this video will pop up. Okay, I think it's about 8-ish minutes, not sure exactly. All right, so let's do the, no, mine's not double-sided, here we go. Let's do these practice problems together, go through these, and then answer any of your guys' questions as we go along. Let's see. So, before we start, and I don't even ask you guys on the test, make sure you always balance the reaction. Here it says balance the reaction, but on the test, it might not even say balance the reaction. And you'll just need to know, oh, I've got to balance this thing. So make sure you don't skip that. Always, always balance the reaction. Okay. So we have a little bit of a messy reaction to balance. We have, let me see, we have 3 nitrates here, 1 nitrate. We got 2 aluminums. So, okay, actually this is not too bad here, right? So what we're going to do is I'm going to start with the aluminums, okay? So I have 2 aluminums here, so I'm going to go ahead and put a 2 right out here in front of my aluminum nitrate. That's going to get me 6 nitrates. So if I have 6 nitrates, I want to have a 6 right here in front of sodium nitrate. That's going to get me 6 nitrates. That's going to get me 6 sodiums, and I have 2 sodiums here, so I need to put a 3 in front of the sodium. That's now going to get me 3 carbonates, and I have 3 carbonates for aluminum carbonate, so I'm all balanced there. So that should be your balanced reaction. Notice how we're balancing the ions, not balancing the elements. That's going to be a much, much easier way to do this. If you're going to balance the elements, it'll take you a lot longer. All right, what type of reaction is this? We notice that we got aqueous, aqueous, 2 different aqueous, everything's switching who they're with, and we got a solid aqueous. That solid indicates that's a precipitate, and this is a double replacement reaction or double displacement. All right, the precipitate, of course, is the solid, and so I'm just going to label it as that. And what does AQ mean? AQ means dissolved in water. So a little bit of review here, right? Dissolved in water. Okay? All right. Now, suppose that we react 1.5 moles, and nice, this is actually a good thing. We have moles to moles in this case, right? We have 1.5 moles of aluminum nitrate with 1.8 moles of sodium carbonate, and after the reaction is done, you collect 0.5 moles of aluminum carbonate. Now, key word here that we're going to watch out for is this collect. That tells us what this 0.5 is, and I want to make sure that we make a note of this before we jump into any kind of calculations. This 0.5 moles of aluminum carbonate is the actual yield. All right, so actual yield, we're going to go ahead and say that actual yield is 0.5 moles of, move this over, Al2CO3. Okay, that's the actual yield. So this tells us a couple things. It tells us, first of all, that we need to do our calculations for this product, for the precipitate, for the aluminum carbonate. And secondly, this 0.5 is not going to be in any of our initial calculations. All right, so pause here. I got a question. I forgot what the precipitate is. Precipitate is basically the solid that forms from a solution, okay? So we've talked about precipitates in terms of double replacement reactions. You can also have a precipitate which would form from a supersaturated solution. So in both cases, you have something that's dissolved and is now turning into a solid. And we can notice it simply because of that solid right there. All right, but I'm not going to test you about that on the test. I just want you guys to keep this stuff in mind and remember the stuff that you guys have already learned. Sorry about that. So the actual yield, excuse me, the actual yield tells us that we are going to be doing all of our calculations for that chemical. Man, dying here. Actually not. Excuse me, just. I am actually not sick. I know everybody worried about coronavirus and all that. I just am choking on my water here. Sorry about that, guys. All right, so back over here. The actual yield, that tells us that we are solving for this particular product. And it also tells us that we are not going to be using that 0.5 in any of our initial calculations. So what are we going to calculate? All right, now back up here. 1.5 moles of aluminum nitrate and 1.8 moles of sodium carbonate. We're going to use those numbers. So 1.5 moles of AlNO3, and this 1.8 moles of sodium carbonate, Na2CO3. Those are our initial amounts of each of the different reactants. And anytime it asks us what is the limiting reagent, we know that we need to start off with two separate calculations, two separate conversions of the two different reactants. So you better have both of these written down here, the starting amounts of both of the different reactants. And in this case, because we're starting with moles and we're solving for moles, it's going to simply be a one-step conversion. Okay, and the one-step conversion is going to come directly from that balanced reaction. If we start with aluminum nitrate, we're going to have aluminum nitrate on the bottom. All right, and so I look back at the at the balanced reaction, and I think you guys can see this here. I look back at the balanced reaction here, and I say, all right, that 2AlNO3 is going to be on the bottom, and what I'm solving for is going to be on the top. But which of them should it be? Should it be this one or this one? Well, I'm going to choose the aluminum carbonate because that's what our actual yield is in. So I'm going to put our 1Al2CO3 on the top. Okay? Which means this is simply going to be 1.5 divided by 2. 1.5 divided by 2. And let's just pause here and just make some sense of everything, right? So what am I doing? I'm taking moles of aluminum nitrate and converting it to moles of aluminum carbonate using the numbers that I have from the balanced reaction. I'm starting with aluminum nitrate, so the 2AlNO3 is on the bottom, and I'm solving for aluminum carbonate because that's what our actual yield is in, and there's only one of them because there's no number here in the balanced reaction. All right, so it's just going to be 1.5 divided by 2. You guys should be able to do that in your head. That's going to be 0.75, or you can use a calculator. Same, it's fine either way. And this is going to be moles of Al2CO3. All right, so from now on, are all the equations on the test going to ask for the actual yield? No, you're going to have a variety of questions on the test, okay? There will be one problem on the test which is very, very similar to actually 6 and 7 down here, and the whole front page is going to go through things like this where it's just simple moles to moles calculation. So, but there's going to be another problem that's not going to deal with limiting reagent, so not everything's going to have all the concepts in it. So you're going to have problems, and you'll see on the practice test, you'll know exactly what to prepare for, right? Go through the practice test, and you'll know exactly what's going to be on the actual test. Well, not exactly, but more or less, right? Different equations, different chemicals, different numbers, but the setup will be exactly the same. All right, back over here. So that is the amount of product or the moles of product that we can get from our aluminum nitrate, but we're not going to stop there. We want to know, what about this other reactant? We have sodium carbonate, 1.8 moles of sodium carbonate, and so we're not sure exactly how much product you can make. Okay, so if we are starting with sodium carbonate, we're going to have our 3 Na2CO3 is going to go on the bottom, right? From the balanced reaction, we got 3 there. But we have to solve for the same product, 1Al2CO3, 3. This is very, very important, okay? The tops of these two different things should be the same, okay? The tops of these two different things should be the same. We need to compare apples to apples. We need to make sure we're solving for the same product, so the tops of these should be the same, okay? So again, simple math here is going to be 1.8 divided by 3, right? Remember, we divide by numbers in the bottom, so 1.8 divided by 3, same as 18 divided by 3 is 6, so this is going to be 0.60 moles of Al2CO3. Now let's look at those answers, right? One of those is bigger and one of those is smaller. The smaller one will be our theoretical yield. Right? Because you cannot possibly make more than that. Once you get to 0.6 moles, you're going to run out of your sodium carbonate, which means that this sodium carbonate is going to be the limiting reagent. Okay? The smaller of those two amounts is the theoretical yield, and the reactant that makes the smaller of those two amounts is the limiting reagent. Last of all, we can go ahead and calculate the percent yield. We already know the actual yield. The actual yield is back up in the problem. This is 0.5 moles of aluminum carbonate. So our percent yield is going to be actual over the theoretical, all times 100 to make it into a percent, which is going to be 0.5 divided by 0.6 times 100, and you can do that in your calculators, right? 0.5 divided by 0.6, and that's going to get us 0.83333, and that works out to be 83%. Just multiplying it by 100 or moving that decimal point 2 spots to the right to make it 83%. Okay? So guys, questions on that one? Anything at all? All right. So just as heads up, on the test, you will have something similar to this. And it's going to be a fill-in-the-blank kind of part of the test. You'll see it on the practice test. You have a bunch of fill-in-the-blank problems, and they will all be moles to moles, one-step kind of things. Right? On the front side, you don't need to calculate any molar mass. Whenever you see moles to moles, you have no molar mass calculations. You're just doing these moles to moles, one-step calculations. And remember, the balance reaction is your conversion factor. Okay? But on the back, you will have to do some grams to grams type problems. And let's just jump into that one right now. So you have on the back side, you've got this problem with iron 3 oxide and aluminum, and that is not balanced. Make sure you always balance the reaction first. So I'm looking at, looks like this one's not too bad, right? So we have aluminum, 1 aluminum here and 2 here. So I'm going to put a 2 in front of that, and I have 2 irons, and I have 1 iron, so I'm going to put a 2 in front of that. And the nice thing about this one is you have 3 oxygens and 3 oxygens, so you don't need to worry about balancing that. It's already balanced for you. So it's pretty nice. A nice reaction. Don't expect something this nice in the test, but hey, maybe you'll get something that nice. You never know. What type of reaction is that? Now, there's a couple different names for this, but the one that we learned is a single replacement reaction. It's not a normal single replacement reaction because single replacement reactions normally have something that's done in water, aqueous. This is not. These are all solids, and this is a liquid. But this is a single replacement reaction. Same thing going on where you have aluminum coming in and replacing the oxygen, replacing the iron getting kicked out, and now you have aluminum with oxygen. So it's a single replacement reaction. Okay. Finding excess. Oh, shoot. I forgot to answer that. Thank you very much. So we'll pause on this and go back up to the previous problem. So sorry about that. I forgot to answer the question of what was in excess. This is our limiting reagent, and this is our theoretical yield. The reactant that makes more or could make more product, or the larger amount of product, that one is going to be the one that there's excess of. So excess. Okay? So whatever's the limiting reagent, the other reactant is going to be the one in excess. So one reactant will be the limiting reagent and the other reactant will be in excess. Okay? So thanks for that. That was a good question. I forgot to address that one. All right, next. Back down here. Okay. So we have 100 grams of iron 3 oxide, 75 grams of aluminum, and we have 54.2 grams of iron that's produced right away. We can say, all right, this 54.2 grams of iron that's produced, that's going to be our actual yield. Okay? And so we can go ahead and solve for iron as the product. And notice that these are all in grams. Grams, grams, grams. And because they're all grams, these are going to be grams to grams conversions, 3-step grams to grams conversion problems that we're going to be solving for. And so we're going to think that we need 3 steps for this. And that's right. So it's a little bit more work on this one. We're going to need to calculate the molar mass of iron 3 oxide for this one. And aluminum and iron, they're going to be straight from the periodic table. So before we even set them up, let's just go ahead and solve for the molar mass of Fe2O3. Right, that's going to be 2 times the mass of iron, which is 55.845. And we have 3 oxygens, so that's going to be 3 times 15.999. Let's total that all up in my calculator. 2 times 55.845 plus 3 times 15.999. Let's type that in wrong. 2 times 55.845 plus 3 times 15.999. And there we go. That is our molar mass of iron 3 oxide, 159.687 grams per mole. Okay? So once we have that molar mass, we can go ahead and set this up like any other type of grams to grams type conversions. This, once again, is a limiting reagent problem. So we're going to write down the amounts of each reactant. We have 100 grams of Fe2O3, and we have 75 grams of aluminum. Notice we have 3 significant figures for both of them. And notice, guys, this is really important. I want you guys to always write down the number, the units, and the chemical. The number, the units, and the chemical. That will help remind you guys how to set this up so you're not making any mistakes. And I'm going to require that you guys write all that, okay? Label everything, number, units, and chemical. All right, 3 steps because these are grams to grams type problems. And for all of these 3-step problems, you're going to see 1 mole in the top left and 1 mole in the bottom right. Because this right here is going to be a molar mass converting from grams to moles. And this right here is going to be a molar mass converting from moles back to grams. Okay? And the middle one is going to be that key stoichiometry step that comes from the balanced reaction. So without further ado, let's put some numbers in. This is Fe2O3, so we're going to put the molar mass of 159.687 grams right in there. We've now converted from grams of iron 3 oxide to moles of iron 3 oxide. Okay? And I'm just getting a question here. Just as the double checking, the limiting reagent is the lowest number? Yes, that's correct. The limiting reagent is the reactant that makes the smallest amount of product, and that lowest number is the theoretical yield. Okay, so that's what we're looking for here. We're trying to figure out which one of these is going to be the limiting reagent by figuring out how much product it can make. Okay, so once we're in moles, we can now go from iron 3 oxide to the product. Which product should we solve for? In this case, it tells us the actual yield is for iron, so we're going to solve for iron. So 2 Fe at the top, right? We're going to solve for iron. If we're starting with Fe2O3, we're going to put Fe2O3 on the bottom. And there's only one because the balance reaction has no number out in front there. Okay? That's what the actual yield was for. We could literally choose either product. It wouldn't matter. As long as these two things were solving for the same product, it wouldn't matter which product they're solving for. But because it tells us the actual yield is for iron, we need to solve for iron. All right? And so this last blank is going to be the molar mass of Fe, and that is from the periodic table, which you guys should be pretty good at looking up by now, right? Periodic table, and we're looking right here underneath it, 55.845. That is the molar mass of just simply iron, 55.845 grams per mole. Okay? So in our calculations, let me just, I don't need to clear that. We're going to do 100, divide by numbers in the bottom, multiply by numbers in the top. So it's going to be 100 divided by that molar mass, which is already in my calculator, times 2 times 55.845, and that's it. That's going to get me 69.94. We'll just round it off to 3 sig figs. 69.9 grams of Fe. Okay? So we've done that so far, starting with 100 grams of Fe2O3. We need to do the same thing for 75 grams of aluminum. All right? And once again, we got 1 mole top, left, bottom, right, because we need a molar mass here and here. And keep in mind the top should be exactly the same as the tops here. So down here is going to go the molar mass of aluminum, right? Because we're starting with grams. Grams are going to go in the bottom. On the periodic table, it tells us aluminum is 26.982 grams per mole. That's going to get us to moles of aluminum, which means we now need to go from aluminum to iron, right? Back at the balance reaction, we noticed that there are 2 aluminums here on the bottom. So I'm going to go ahead and put a 2 Al down at the bottom. On the top, we should have it converting from aluminum to iron. So I'm going to put a 2 Fe here on the top. All right. And then last of all, we need the molar mass of our product of the iron. So that's going to be 55.845 grams. One more time, notice that the tops of these conversions are the same. The tops of these conversions are the same. Why? Because we are solving for the same product. We're solving for Fe in both cases. Okay? And if you didn't know which to solve for, you'd need to make sure you solve for the same product. So in our calculators, that's going to be 75 divided by 26.982 times 2 divided by 2. So we just can literally ignore that. That's going to be just 1. And then finally, times 55.845 gives us a pretty big number there, 155 grams of iron. So let's pause and think about that. We have 2 different numbers. One of those numbers is the theoretical yield. Which one? Which one of those is going to be the theoretical yield? The smaller one, of course, right? The smaller one is the theoretical yield, which means the reactant that makes it is our limiting reagent. So let me go ahead and label those. This is the theoretical yield, and Fe2O3 is our limiting reagent. Limiting reagent is Fe2O3. And last of all, if we want to know what's in excess, that's going to be the other reactant. Okay? Aluminum is in excess, or there's an excess of aluminum. Okay? And I believe it does ask what is the percent yield. And so the percent yield for this one, we have, do we have an actual yield? Yes, that 54.2 grams. That's going to be our actual yield. So the percent yield, I'll just do up here, is going to be the actual of 54.2 grams divided by the theoretical of 69.9 grams, all times 100 to turn it into a percent. So I'm going to do 54.2 divided by 69. And I'm going to go ahead and write 943 just so I don't have any rounding errors. I like to do that. To get my final answer of 0.7749, we have three significant figures, so we're going to round that 49 up to a 5, and that's going to get me 77.5% yield. 77.5% yield. Of course, just multiplying that by 100 or move that decimal point over, you get 77.49, which is 77.5%. So, that is it for the homework. Do you guys have any questions? We have nothing new that I want to go over. No new concepts, no new nothing like that. Just your practice test to go through. So, do you guys have any questions for me before we just end here? And hopefully you guys, the live stream is working out for you guys. I see 11 people on now. Hopefully it's working out. All right, you got it. Awesome. You got it. Good, good, good. All right. And the number one thing that's going to help you guys on the test is to go through that practice test without any help. You try to solve everything on your own, okay? Go through that practice test, solve everything on your own. Awesome, Connor. Glad that you understand now, right? But please go through the practice test, try to solve everything on your own, and then we're going to go through the answers on Monday and to correct yourself. And even that, you can try to go through the practice test on your own and then look back through your homework and see to make sure that you can do everything in there. All right, and do your best on that practice test. We'll go through the answers on Monday. I believe I've already posted the answers on OneDrive, but don't look at the answers before you go through the test. Make sure you go through that practice test on your own. And then when the test day comes, it's open notes, so you can have that practice test out, so you can go back and look at what you did to make sure that you're doing it right, okay? But because it's open notes, the most important thing that you can do is to go through practice problems, make sure that you can solve those practice problems. Okay? But otherwise, have a great weekend. All right? Any questions about the test or about anything else? All right. Have a wonderful weekend, everybody. Stay safe. Have fun. Watch some TV. Not a normal advice I give you guys, but watch some TV. Go outside, get some sun, but stay away from people. I mean, seriously, it's looking pretty bad. Especially in New York City, as you guys probably watch the news and all that, and we're pretty close to New York City. Some people in my church also getting the coronavirus. So just, be careful. It's in Connecticut. It's here. Be careful. But have a nice weekend. Get your rest. Get some sun. Enjoy yourself and practice for the actual test. All right. See you guys.